What's going on, everyone? Embedded Monk here, and this is Embedded Adventure Day 23, where I'm as a complete monkey trying to do cool stuff with embedded systems, trying to make a cool project, maybe get a job. In previous series, in Day 22, I told you that I'm gonna do a project. I'm gonna do a portal gun from Rick and Morty. Yeah, and I'm here to share with you some progress that I have made in past 3 days, and also to make something more. So, first of all, yeah, let's just jump into it. Yep. First of all, I'm gonna show you. I write all ideas that I had about this portal gun. All ideas. By the way, it's actually you can see it. I have a link in the description to this thing. So I decided to divide this whole thing into three modes. These three modes will probably be changed. Like I probably will take something that like some wheel that can be spinned here and change the mode, but I decided to divide with three modes. First mode is the most basic one, so you probably just toggle the button, portal opening, some sound, and of course lights and projection on the wall. And that's all basically. And you press and it closes with sound from Rick and Morty. But you probably guys, if you watched Rick and Morty, you probably remember that game, the Pocket Mortys. Yeah, Pocket Mortys. That's amazing game, guys. I spent like hours playing that game. That was super cool for a phone. Like I played it on my phone, and I decided why not make like some kind of integration of that game into the portal gun. So I made like two more modes. Mode 1 will be about the capturing Mortys. So you're just like randomly some notification comes here and you have to do some action to capture the Morty. And then you can actually see the Morty on the screen. So that's the whole idea basically. Yeah, so basically you catch the Morty or you don't catch it. Yep, and you can choose and see the stats of each Morty. And the second mode, it's actually the most hardest one, that's why it's red, by the way, is the multiplayer. I currently don't know how I will implement this. Some kind of, like two guys with the same like portal gun meet each other and battle with their Mortys that they have here. So yeah. Oh yeah, and by the way, one more interesting feature that I forgot to add. No, like storing between charging sessions. Yep. Because that's pretty important to have, like, to use the internal memory of the ESP32 to actually to basically create it, like have a player count. So basically a one portal gun, one player. So you will have like an inventory here with all your Mortys that will be stored on the ESP32. Yep. So that's the whole idea. First of all, I'm gonna implement the mode 0 because it's the most basic one, and let me show you one more thing. What I have ordered for that. Yep, I probably will post it in the Telegram channel. I currently don't know, but okay, guys. So I've ordered different things. I ordered like I'm gonna show you what I ordered specifically. One moment, I'm gonna just translate it. So I ordered a tact switch, basically just a push button. I ordered a battery that will power up all that thing. Battery holder. Also a very important thing is a DC to DC converter. Well, I don't know, basically ChatGPT said that ESP32 takes only 5 volts. So if it takes 5 volts, then 4.7 volts from the even 3.7 volts is obviously not enough So I ordered the DC to DC converter, which actually allows you to amplify the voltage to 5 volts. I also ordered a very fancy toggle switch, so probably gonna use it. Yeah. And of course, I ordered a lot of soldering things that probably I will need. I'm gonna show you them quickly. Here, so I ordered a flux and I ordered a soldier, because, well, if you haven't seen, I probably will leave like the shirts here. I made a shirt about my first ever soldering, which was absolutely total disaster. I ruined everything, absolutely. So I learned my mistakes. I've ordered a separate flux. I ordered a good soldier. Perfect. Yep. Probably that's it. I also ordered a speaker, but I currently don't know. Probably will just stick to the lights and to the opening and closing the portal. Yep. Okay, so basic task for today is to make a schematics. So to make a schema of the whole project. Yeah, so I actually asked ChatGPT which tools it just actually can recommend. I know the keycard tool. It's like extremely actually, well, it's not that easy. It's not that easy. It's more professional. So I just don't think that Portal Gun is actually that that of professional project, you know. So I just decided to. Also, the fritzing, you know, actually I used fritzing in school when we had like some, like we had like circuit design class. It was very short. It's like what's in back in 2020. Yeah, and fritzing. Well, I didn't really like it, but probably we can use it. And I found like I haven't heard about it, like EasyEDA. EasyEDA. Probably that's interesting to try. So I just think we just need to jump straight here. As I said, I'm total monkey, so probably we're just gonna create some dumb thing, but nevertheless, new standard project. Let's try this out. I'm just curious. I have to log in. Okay. What should we call you? Call me Embedded Monkey. Of course. Yep. No, I don't need some help. Yep, just personal. Probably, yep. Next. What do you mainly use EDA for? I don't know, create some schematic diagrams. Beginner, absolutely monkey. Cold. Embedded monkey. Let's go. Next. Hell no, design online. Give me the editor, give me the editor. Here we go. New project, new standard project. Let's just call it Portal Gun. Okay, save it. Pretty nice interface, by the way. Okay, so first of all, let's explore some symbols. I currently don't know what I can use here. So okay, voltage around, that's pretty okay. Resistor, capacitors, inductor, power supply. What's that? It's like a LED? No, it's actually probably not an LED connector. Okay, some switch. By the way, I need a switch. Diodes. That's cool. Is there a battery or something like that? Probably need a battery. You know, like I want to use actually a battery here. But all libraries, all. What the hell? No, I just wanna GLCB parts. What? No, please. I just want to use some standard battery pack. Is there a battery thing? Actually, I can't see here. You know, I thought like it's probably a good editor, but I wanted to make it like, oh, maybe here, volts, 5 volts. No, actually, what is that? Probe, pin. I actually like, in that sense, I like fritzing more, because fritzing, you know, have like all this visually, so probably I would actually like to use fritzing for that purpose. Let's try to download it quickly. Download, yep. What the hell? October. Pay and download. Why? I remember it was free. I remember it was free actually. That's actually strange. Fritzing. Download. Fritzing using the official download links. Damn, I actually... One moment, guys. Okay, guys, so I managed to install fritzing a little bit illegally. I probably won't tell you how I managed to install it on YouTube. If you want to also install fritzing, check out my Telegram channel. I will post the way there. Okay, so finally installed. Yeah, there are pretty cool elements here. Let's try to make a schematic for... Okay, so what do we got here? I'm interested. I need a battery, probably battery holder or something like that. Because that's like first thing that actually will power up the whole... Yeah, here we go. Here we go, by the way. Yep, so... Oh, it's like that thing. Okay, what about breadboard? Oh, yeah, that's what I mean. That's what I mean, actually. I want to actually edit it here. Because, wait a second. Okay, it just seemed more convenient for me to actually you know, just see the elements here. That's actually easier for me to understand. Also, the charger. I wonder, is there a charger here? Like, power plug, no. Voltage regulator. By the way, we need a voltage regulator, so I will probably use it. Yep. By the way, it's quite strange here. Like, I can't probably show you the voltage regulator that I have ordered. It's a little bit different. I'm gonna quickly show you. Yep. That's how it looks like. That's how it, yeah, let's just open it in separate tab. Yeah, so it just takes the inputs, takes the outputs, and here you can actually change the output value to like 5 volts, 8 volts, 9 volts. And here, well, maybe like location, rotation, decrease. Maybe it also has some of that parameters, so voltage 5 volts. We can actually make it variable, so it can be actually, well, it's pretty strange for a voltage regulator. Meshing part found, freeze and choose the close mesh. Okay. Well, alright. Let's just open it here. Is there any like ESP board? Yeah, by the way, here's the EasyEDA fruit board. Yo, Like fritzing is actually cool. I actually like it. Yep. Resbio. No ESP? No. That actually seems like it looks like ESP. Well, I guess for now we can actually take something that looks just similar to ESP. Yep, so the whole idea will be just to power this up. We don't even need a breadboard here, probably. Wow. There's actually more cooler elements there. Spark Fun? No. Probably there's just like different manufacturers of that thing. Different sensors. Cool. Yo. That's actually cool. Okay. We also will need some push buttons, so I probably will use that. Also Arduino, maybe. Well, actually, Arduino have like different. Oh, whoa! 1 moment. Just gonna quickly close the Telegram here so you won't see. Yep. Maybe Arduino have some interesting parts. Okay. Arduino feel funnel output. Damn, that's actually cool. It's actually cool core. Yep. So we have a battery. By the way, can I use like one battery here instead of two? Voltage, 3 volts, 4.8 volts. Oh no. So I can't use less than. I can use probably. No freaking way I will use 9 volts to power up the ESP32. I guess it's just like an overkill, but. I've actually ordered the thing. I will show you. It looks like this. It actually looks like this. So it only holds one battery, one 18650 battery. So it can power up to 3.7 volts if I'm not mistaken. Where's the accumulator? Yeah, 3.7 volts. Yep. Okay. But okay, let's leave it like this. I just wonder, are there any connectors here? I also want to use some connection. Well, can I? Whoa, that's sick. That's actually sick. Let me, by the way, remember where are the pins. So the input voltage is actually here. Yep. Well, at least on the ESP32 that I'm holding right now is just, well, you probably won't see them. Here are the 2 pins, like it have 2 pins for output, 3 volts and ground. And here it has like 2 pins for voltage input and I guess ground. So probably I will stick just to what I see there. Yo, what a good editor here. Yeah, damn. Okay, so then I'll probably use. Here's the ground. Yep. Okay, so actually no, we still have to use amplifier. You know what? Like it's 3 volts, so we need to have amplifier. Let me think. Are there any amplifiers? Let's just simply Google it. Fritzing voltage amplifier. Yep. Alarm 358. By the way, probably we can actually... Can we find exactly this one? I'm just interested. I don't really know how it's called, but SS14. Well, no, okay, you know, let's just simply try to search. Yep, here we go. 358 dual operational amplifier. I have 356 and 358 dual amplifier. Actually, there are a bunch of them, so we can have it like that amplifier, and that amplifier. No, they are just actually probably different packages, I guess. Well, let us use that one. Yep. Let's use that one. LM 358. I'm just interested, like, you know, I'm interested like in this case. Everything is pretty obvious. We have inputs, we have outputs, and we have two connections to regulate the voltage. Yep. Here we have like 8 of them. Like that's strange. Okay. Let's just check this out. Let's continue. Okay, so just wanna check the inputs and the outputs of that element. Yep. Okay, so basically that's how it should work. It takes some inputs. Oh, it takes actually 2 inputs here. Inputs A, output A. Inputs B, outputs B. Interestingly, how it works. You know, let's just ask GPT how it works. Just gonna quickly do the screenshot here. Okay. Just quickly. What the hell? Oh. Gotcha. Gotcha, brother. Gotcha. Oh. Wait, no. GPT. Yep. Okay, can you explain the like inputs and outputs of the LM358 voltage amplifier? Here is the schema. I call it vibe embedding, brothers. Vibe embedding. The LM358 is a dual operational amplifier, 2 independent operation amplifiers in one 80-pin package. So pin 8, positive supply voltage. Pin 4, negatively supplied voltage. Okay. So basically just regular voltages, okay. Non-inverting input voltage goes up, the output tends to go down. Pin 1 output A, inverting A, input A. Okay, I just have I have a battery that gives 3.7 volts, and I want to get stable 5 volts. How should I connect it through LM 358? Yep. Get a stable 5 volts from really better using it alone. You should use instead. Not a power converter. It cannot boost voltage. So these are actually different things. Oh. So operational amplifier and DC-DC converter are actually different things. That's pretty insightful. What's the difference between operational amplifier and DC-DC boost converter? That's actually interesting. I'm not a big specialist in electronics, you know. I had it at university, but I passed it with the E grade. You know, there's like an F grade, like the most horrible, like you failed. Yeah, basically. And the E is like the lowest. You haven't failed, but it is the lowest grade. So I have E on electronics. Yeah, back like 1.5 years ago. Damn, almost 2 years ago. Okay. Mm-hmm. Mm. Okay. Okay. So OP amplifier is actually for some small signals to actually amplify them a little bit, but not higher than its input voltage. Yep. Probably like that. See, a boost converter is a power converter, so convert electric power from one voltage level to another. Okay. Switching, inductor, diode, and capacitor. It's actually interesting to explore how it actually happens. So how the voltage is actually goes from 3.7 volts to 5 volts stable. Yep. That's quite interesting. Okay. Okay, what if I just like find in fritzing? So okay, that shit goes off here. DC, DC. Here we go. Here we go, guys. There are plenty of them, as far as I can see. Probably none of that is actually relatable. Like, okay, if I will enter simply DC, DC boost. DC to DC booster. And here is also a booster. Well, let us see what it's doing. the hell? Yeah, you know, it's something wrong. Maybe that shit. That actually seems relatable, but no, for some reason it just have extremely lots of, you know, like different inputs, outputs. I want to go to schematic here just to check. Um, You know, it's actually a voltage regulator. So probably if we tie it here, it will tie there. Yep. Let's try and tie it here. So the thing is, I want to get from the battery. Yep. From the battery to that amplifier. Okay. So let's try and connect it. Wait a second. So it's just like, okay, I guess this one is input voltage. Yep. Alright, let it be like this. A little bit broken. Yeah, I'm not very good at. Okay, let's just amplify it here a little bit. Okay, and also we also should put the ground there. Also should put some. It's actually very inconvenient to work without a mouse here, but okay. So basically like that. Yep. Yeah, basically we're taking that thing here and getting the output voltage, which goes to, by the way, are they connected here? They're actually not. They're actually connected to a different thing. Okay, okay. So, and what is that then? What is that on schematic level? Oh, so that's a whole different thing. That's actually a whole different thing. We actually have here the input output, and that's actually much less intuitive, so we'll use this one. As simple as that. Yep. Okay, let's remove that thing from here. So we got the output voltage, which goes to, actually not here, it goes to switch. We need a switch. I also ordered a switch. It's very fancy, guys. You will check this out. It's very fancy. I hope it will be delivered in time. Okay. Just a basic switch. Yep. Just a, like, close. Yep. Rotary, no. Yep, just basically... it's not that intuitive, actually. I just want to... Yeah, something like that. No. I know they're actually all the same, probably. But I need not the triple one. Yep, not the triple one. I need more like, because the triple one is basically a transistor. Well, yeah, the transistor, if we put an appropriate voltage to the base, it actually either closed or open. That's how it works. Yep. Okay, so more like that. Need more like that, but just looks a little bit awkward, but okay. Okay. So let's connect it then. Yep, let's connect it. Can I? Nope. Nope. Just want to connect it, please. It actually won't connect for some reason. What if we go to schematics and try to do it here? Actually, it's pretty cool that, you know, it's cool that I can edit something in breadboard thing, then look at schematics, see absolutely the same thing, and then go to PCB code. Well, I guess I can write a code for Arduino here. Damn, I love fritzing. I actually love fritzing. That's cool. That's cool. But okay, let's switch back to building schema. So that's how I connect that thing. Okay. Basically the same shit. Okay, and now I want to connect it here. Yep. Directly. Or no. I just want to simply tie that up here. Yep. And then, of course, we need to ground that up. And then there's a mess here. That's actually a mess. Let's just make it a little bit more beautiful. Yep. Or no. Can I? This actually looks awful. That looks awful. Alright. And to actually... I want actually to get this lag here. Get this here. Okay, or just simply here. Yep. No way. No way. How to connect them back? So are they connected? This thing is actually not connected. It wasn't connected, I guess. It actually won't connect. By the way, it won't connect. For some reason. That's strange. Like, why? Look, guys, I just moved that here. It does not connect. For some reason. Okay, what if I will do it as schematics? So in schema, it's actually connected. So it's actually tied here. On the breadboard, it's not. It won't connect. Here, can I just make it smaller a little bit? No, hell no. No, I just will recreate that thing. I will just remove that battery from here. Take the new one. Fuck it. Just fuck it. By the way, there is a single battery handler. There is an actually single battery handler here. Yep. But is there a holder for it? That's a big question. That's a big question. Is there a holder there? I can see only the... Who the fuck created that thing? Power on off. Damn, I probably won't have like this kind of holder. My holder is just freakingly holding and powering that up. So, no, let's actually use a single battery, but in an appropriate way. here's the, no, here's the battery. We have to place it just here. Yep. Okay. So tie that thing here, that thing here. I hope I'm not mistaken by what is ground and what is not. By the way, it's important to check. It's important to check. Let's check that. Battery schematics. No, battery schema symbol. Plus and minus here, so actually the voltage is here, the ground is here. Oh, I fucked that up. I fucked that up a little bit. I actually need to connect voltage here, ground here. Yeah, but of course do it in a fancy way, like that. Okay. So that looks much better. I guess in breadboard it's also connected. Somehow it's connected, okay. It's not that cool, but okay. I guess I can actually make it better. Like that, yep. No? Can I? Fuck you, man, fuck you. Just simply, yep, finally. No. Freaking hell. I'm actually not very used to it, but probably it's also because I'm like using, no, they're actually not connected. How the fuck? Yeah, so now they are connected. I just wanted to, like, you know, move that connection a little bit, but I actually can't really move it in a good way, so it look like not awful. I don't know. I just like the, like, a little bit of perfection here. Yeah, but now let's just start again. Probably the third time it will actually do something. No. Hell no. Yep, here we go. So that's what I've been looking for. Damn, I don't like, because it looks really awful. It looks extremely awful, guys. Like, I hate how it looks. It's absolutely disgusting. Maybe if I hold Alt, it will do something. No freaking way. That's actually better. By the way, I want to save it somewhere. I want to save that freeze sketch to the embedded monkey folder just to not lose it. I'm just a little bit afraid of losing anything. Untitled sketch. Best name, yep. Okay. So let's just continue. Okay. So we connected, finally, what have we done? We connected the voltage to the DC booster, and then we connected it through the switch to the, let's assume that is an ESP32 board, but actually, well, I wonder, is there a real ESP32 here? No ESP32. For real? No ESP? Freaking hell. There's actually ESP Ruino. What is ESP Ruino? Yo. ESP Ruino is actually cool. But let's assume that is an ESP because it's actually, it looks familiar for me. Yep. As for the ground, I guess we just simply need to connect it here. Probably. Or no. Well, actually, yeah. Seems okay. I'm just currently don't really know where I should connect it, but I'm just gonna do it intuitively a little bit. Yeah, so intuitively we connect the power through the DC-DC booster to the ESP32, then it goes to the ground. Okay. Now what? LEDs. Yep, finally. So we powered that up. Now we need some LEDs. We need some... No, we actually need a button. We need a button. Let's find a button. Yep, we need a button to connect it. Okay, to connect it to the some GPIOs. So this button will actually be somewhere here. We'll just simply click it, and lights will glow on, off, and some sounds will create some sounds, of course. Okay guys, so probably to not make this video too long, I'll probably finish that thing tomorrow. I guess I will record another embedded day, yeah. And I hope tomorrow we'll finish that thing. If you enjoyed the video, hit the like, subscribe, leave a comment. Maybe you have some suggestions for my Rick and Morty project. Yep, I hope that I will get my elements delivered soon. I actually was promised that they will be delivered like tomorrow, but now they say like 5th of January, which is the day after tomorrow, so okay. Yeah, but we have work to do. Yep, so tomorrow I will probably finish that schema. Yep, so like, subscribe guys, and see you tomorrow. Bye.